So, hello and welcome to the broncolor studio once more. My name is Urs Recho. This is webinar number 7. 7, that's an odd number, and this means that today it's a product insight, not a live shooting like a week ago, like next week, but product insight. Today we talk about continuous light, and we talk about this lamphead here, which is a broncolor LED F160. Very quickly, I would like to let you know how this webinar is going to happen. So I will first cover a couple of technical aspects. I will talk about the power. I will talk about the different aspects of color. Then we make a first short break about questions. So if you have basically a question about the specific technical aspects of the light, that's the moment. Then we jump into physics, a little bit more physics of light, of reflectors, different shapes of reflectors, and where a light source has to be inside the reflector, that these reflectors are effective, that we can actually shape the light properly. And then we go on and have a look at a couple of photographs that I took with this light, let's say on location in the studio, mixed light situations, and so on and so on. Right. Okay, that's pretty much it. As I said, you have about, after 20 minutes, 25 minutes, you have a first round of questions that you can ask me. And of course, I will have a second round of questions at the end of the webinar. However, if you have a question which is maybe not related to continuous light or especially to the LED F160, in 2 days on Friday afternoon, 2 p.m. Swiss time, I will be here in the studio again and answer your questions on the broncolor Instagram channel live. Okay, let's dive into it. It's mainly based on a PowerPoint presentation. I will interrupt it once in a while to show, let's say, batteries and diffuser. We will meet the light live here as well during the webinar. So once in a while, I will interrupt the presentation, but it's based on a PowerPoint presentation, which I'm going to start for you right now. All right, let me check if it shows up. It does. Yes, okay, wonderful. So shaping light with LED F160 product insight, that's what it's about today. Shaping the light with LED F160. We talk about power, we talk about color, open reflectors and closed reflectors like softboxes, special reflectors, some of them. We have a look at how LED can be beneficial for still life photography, and that's as well absolutely suitable to work with it on location. Last but not least, I will explain or show a couple of examples how it can be combined with flash. And this is already a very tiny preview to next week webinar about the same subject. I will have a dancer here in the studio. We will do a live shooting again, and I will combine flash to actually freeze movement of a dancer with continuous light to show the same movement at the same time. So that's what we talk about this afternoon. Subject number 1 is power. So the lamphead is called LED F160. F stands for focus. I will talk about this later on. 160, that's the power that goes in. We can adjust the power over 5 stops, so from 160 watts down to 10 watts. This is 5 f-stops of power range in the end. Most of the time, I end up with to work between 9 and 10 most of the time. It's a little different than with flash photography. If I work with flash, especially in the studio, flash gives me a certain aperture. And then I choose this aperture on the camera, or better the other way around. I choose it on the camera, and then I program the flash that it does exactly what I want it to do. So it's a very direct interaction. Here's a different story, because with continuous light, I have aperture and shutter speed, which is relevant for the correct exposure. So if I want to work with a specific aperture, I can either dial down the power of the LED, or up, of course, or as well I can control this very conveniently with the shutter speed on my camera. And having a shorter shutter speed, most of the time it's beneficial because it freezes or it stops the movement, and it allows me, let's say, to work without a stand. And if we have a moving model as well, it kind of stops the movement. So it's actually, that's why most of the time we work with rather high power on the LED and with a rather short shutter speed on the camera. These 160 watts doesn't sound like a lot, but it's LED. And LED are very light effective. So even if we put in only about 160 watts, there are, if we compare it with tungsten, like normal modeling lights, if I pull the G or whatever modeling lights you have around, it corresponds to about 650 watts tungsten light or tungsten modeling light. And it compares to about 100 watts HMI. So per watt, HMI is still a little bit more effective regarding light output, but of course has as well different disadvantages. There I will talk about this as well later on. So now we have it, we know more or less how much light is coming out. At the end of the presentation, I will show you a couple of photographs, as I said, that I've taken with the LED, and there you will get all the technical data. So what's the sensitivity of the camera, what's the aperture, what's the exposure time, so you will really know in photographic terms how much light is this. I'm asked a lot when I talk about 160 watts, oh, how much is this in zero? So how much is this in flash? Can I compare this with flash? And the short answer would be no, you cannot compare it. You cannot compare flash, which is measured in watt seconds or joules, that's the same. However, continuous light is measured in watts. So we cannot, in the end, we cannot really compare it, but I try it anyway. Let's say we have these 160 watts and on full power, and we expose on the camera side during 2 seconds. So this means 160 watts times 2 seconds. This is 320 watt seconds or joules. And that's extremely close to 400 joules of a flash. Okay, that's a theory. So this means that if I expose the LED during 2 seconds, I get a more or less the same amount of light hitting my object than a full power flash with 400 joules, so a full power flash on a Xerox 400S or 400L. That's a theory, but I wanted to prove here in the studio if this theory actually is true or if my calculations are completely wrong. They were not completely wrong, but they were wrong in the good direction because there's actually more light coming out of it. And the praxis test here in the studio showed that I have to expose the LED F160 on full power during 1 second only, and then I get the same amount of light hitting my object like a 1 full power flash with 400 joules. Okay, so that's the praxis, just metering the lights in the studio, and I came out with this thumb rule. Right. Okay, so much about the power. Let's have a close look at the color. We will have a look at 3 aspects of the color. First of all, the Kelvin, so the color temperature, then green magenta shift, and last but not least, we will have a look at the how precisely this light can reproduce colors. Okay, so we will talk about CRI, color rendering index, and TLCI. I tell you later on what this means. Okay. So we can adjust the color temperature on the LED F160 between 2800 Kelvin and 6800 Kelvin. And we have 2 presets. We have a preset at tungsten balance, so that it's yellowish like normal modeling lights in your studio, 3200 Kelvin preset. And we have another preset on daylight balance, 5500 Kelvin. These are the 2 presets. So with just 1 button touch, you switch between the 2 color temperatures. But we can go, let's say, warmer than tungsten, and we can go colder than daylight. I would like to show to you what this means in photographs. So these 4 pictures show a neutral object, just a white chair in front of white background, not too far overexposed that we actually can see the colors carefully. Camera balance, camera white balance is to 5500 Kelvin, as well as the LED here in the picture in the middle at the lower end. Okay, so the chair that looks neutral, background looks neutral. There we have daylight balance on the light and on the camera. If you go to the upper picture, still in the middle, but if you go up, this is the camera setting remains the same. So the camera is still on daylight, but now on the LED, I chose tungsten. And then, of course, we get the dominant shift into warm tones. And then the two extremes on the top right and on the lower left. On the lower left, we have 6,800 Kelvin, camera still on daylight. And on the top right, we have 2,800 Kelvin, camera still on daylight. So this is the variation range. You can adjust your lights. And not in these huge steps, as I show it here, but in very precise steps of plus minus 50 Kelvin. And this is much more precise than any gel filters. So if you want to make big steps, let's say a really blue background, of course you can still use gel filters. But if you really need tiny adjustments, that one light works perfectly with the other one. It's a huge benefit if I can make the fine adjustments directly on the light. Okay, so this is the most basic look at color. It's just the color temperature. But let's have a look at this diagram. The color temperature here is more or less the horizontal bar from the blue towards the red. That's the color temperature. More on the left, we have the cold colors, the blue colors, higher Kelvin numbers, 10,000, something like this. And when I'm going to the right, to the red, I have the lower Kelvin numbers, 2,500, 2,000, stuff like that. But that's only half of the truth of my light. Okay, what happens in the vertical axis? This is more or less rectangular to the Kelvin line, and there you see the higher I go, the more green it becomes, and the lower I go, the more magenta it becomes. Okay, so if you shoot with your digital camera, if you have a capturing software, you can go into the white balance, and there in the menu you can let's say if you put a gray card there and you tell the camera this is my gray card, then you can see the readings on your camera. So the camera chooses the corresponding white balance regarding the kelvins. So it tells you, okay, if this is supposed to be gray, then I want to shoot at 5,800 Kelvin. But there is always, or most of the time, there's like a second indicator as well. Most of the time, this is called hue, H-U-E. And this is the other axis. This is the green magenta axis. And again, it's very convenient that if I think that one of the lights looks a little bit too magenta-ish or too greenish, I can fine adjust this. Again, if you work with one only light, you just put the gray card there, click, done. Okay. But if you start combining the lights, it's very essential that the lights they all have the same light characteristic, the same light color regarding Kelvin and the hue as well. So in this situation, it's very convenient that I can really fine tune the different lights in my set that are exactly the same. Right. So how does this look? Also, first of all, yes, we can change the green magenta shift, and this depends on the Kelvin setting. Why? Let's say we go all the way to the red. So we have a very warm light. Kind of reddish, and I use mainly all the red LEDs already, of course I cannot add a lot more magenta, because magenta is very close to red. So the redder or the more red I go, the less I can actually push the light into magenta. So the variation range on the green magenta axis depends on the Kelvin settings that I'm choosing on my lamp head. Good. What does this mean in pictures? So again, the two chairs from below, I do not display here the neutral one anymore. So the camera is again set to neutral daylight, and then on the right I have a plus 25 magenta. On the left I have a minus 15 green, and this is about the range. So it's not as dominant, as prominent as the Kelvin color temperature shift that I can do, but it's for all applications, it's absolutely enough to do the fine tune on this axis. Right. So I'm almost finished with the explanations about the colors. So if you have a specific question about these technical aspects like power and color reproduction, that's now the moment to type in your questions. And then after the next slide, I will go and make a short break and answer these questions if there are already some. Right, so shaping the LED, we still talk about color. LED is a cold light. What does it mean? I am not referring to the color of it. We have just seen that we can adjust the color to whatever we want. A cold light means that it does not emit any light because it's very hot, like the sun, or HMI. An HMI bulb as well gets very, very hot. That's why it's emitting light. The same with flash. At the moment, when a flash tube is firing, it's the gas inside the flash tube is extremely hot. That's why it emits light. These hot light sources, they have a continuous spectrum. So even from the lights, it starts in the lights that we don't see in the ultraviolet, and then it goes through all the visible light. Starts with the violet, goes to blue, green, yellow, red, and then shifts away into infrared, which again we can't see. But every length wave of the visible light is part of the spectrum if the light source is hot. It's a different story with LEDs, because these are, you can actually touch an LED. Well, you should not, but you can touch and you don't burn your finger because the LED itself is not hot. There's a lot of heat produced in the back of the lamphead, but the light itself actually is not hot. And these lights, also this is, first of all, I just mentioned it now that I don't forget it. This is a huge advantage, for example, for food photographers. Let's say you have here freshly prepared food and you want to light it. If you do this with HMI or with hot lights, of course it will heat up the product. It will oxidate very soon, and whatever your vegetables will not look fresh green for a long time. So you will have to recook and recook and recook. So with LED, it's a very unaggressive light for sensitive surfaces. The same for macro photography. Let's say you shoot the wings of a bug or of a fly. If you flash this, there's so much heat produced at the specific moment that you can easily burn such filigrane surfaces. And this is really a big advantage of the LED, that all the heat is in the back where we can properly take care of, and the front does not suffer from a lot of infrared or ultraviolet light, so no heat and no aggressive ultraviolet light. Why? It's a line spectrum, so we can very precisely define which wavelength should be produced from our LED. So we can control the light, but it's very difficult to have a very nice color reproduction because there are some colors missing in the spectrum, and we have to select our LEDs and control them with very advanced software. We have to control them very nicely, that we have as many lines as possible, that the perception of the light is as close as possible to daylight. And to measure this, we have two methods. The first one is the CRI, and it's the color rendering index. And there I've actually found the data in our data sheets. And we have a CRI of above 97. 100, that's the sunlight. Okay, that's what that's the perfect light. Is 100, that's the sunlight. That's what our eyes are used to. Talking about our eyes, that's just the next point. CRI is subjective. So the CRI is defined on the human perception of colors. So it's not really scientific. Okay, so it says, okay, this color looks good, like I see it, it looks the same on the photograph or on my screen. So we have a very high CRI. It's maybe, it depends on the industry, it's maybe more common to talk about TLCI. So now I know, I can read it, what it means. So it's Television Lighting Consistency Index. That's the shortcut I forgot before. And there I didn't find any data in our leaflets, but I did find Seconyx SpectraMaster C7000. And let's go for this metering here live and see what we get. So first of all, I take the reflector away because I don't want the reflector or the diffuser to have any influence on my metering. Switch this one on. Okay, and then I make this later. Then I go to TLCI. I want to meter this. Okay, I go to full power just to make sure that I have some additional lights here in the studio, that they are not affecting this measurement. And now if I hold the light there, you see how bright it is. So yeah, the rest of the lights that I set up for filming we can forget about those. It's really just this light that I'm metering now. I'm on 5,500 Kelvin, full power. So let's get this done. I hold it here, some 40 centimeters distance. Meter it and quick checking the value. And it's absolutely a value that I want to share with you guys. Just changing the camera quickly to this built-in camera. And now I hope that you can see this. You see 99. Okay, well, it's not sun because I closed the door, but we have a TLCI here of 99 live metering, and that's good. That's very, very good news. So LED is set to be quality-wise on a lower level, not this one. Okay, we really took very good care of this LED. And the light quality is it's amazing. So the colors you will get when you shoot with this LED are just great. So I think you're too close to me, so I put you a little bit further away again. So this was it for the first part. I would like to have a quick look now at the questions. Let me close this. Oh, and I want to turn this one off as well, because the webcam always compensates and it makes me too dark. So how about aging of the LED, and would it require to fine tune from time to time? The LEDs, they do not really age a lot over time. They are very heavy as well. Let's say if you do something like this to a modeling light, especially during while it's hot, you instantly replace it. LED are very tough. Okay, they can take a lot. Whenever you switch the light on, it checks if there is a new firmware available. If yes, it takes the light about a minute to download it, to install it directly. So if ever we can improve the light for you, we do this with a firmware. And whenever you switch on the light, of course, if it's connected to if there is a internet environment around, it checks if is there something new, it downloads, installs it directly, and after 1-2 minutes you are ready to go with the latest firmware. How many lumens does the F160 produce at the maximum power setting? For this, I have to check the data sheet. I'm not aware of this. Lumens doesn't say anything to me, to be honest. I care about the aperture and exposure time and maybe sensitivity. Lumens doesn't say a lot to me. Maybe I get this from the colleague that is actually checking all this. Maybe you get it directly in the chat. And if not, yes?
We have actually answered. So it's 13,800 lumens.
13,800?
Yes.
Okay, thank you very much for that. Okay, so this is answered. Can we compare different LED lights just based on the wattage? No. Very good question. The wattage what's going in is always one side of the coin. Okay, it's like the engine of a car. If the car has, I don't know how many horsepowers, you have to bring the power on the street, right? The same is here. If you put in 500 watts, but no light reaches the object because our reflector is lousy, or I will talk about the diffusion attachment later on. So of course you get a certain idea. Is it a very strong, is it a high power LED or is it a very low one? But to have a precise comparison, you have to meter the light let's say with a corresponding reflector, both normal reflectors or as well bare bulb, that you just compare bare bulb and bare bulb. And then you have a fair and reliable comparison between two different lights. Okay, exactly. So these are the other factors. We will talk, actually, very good question, because it leads me directly to the next subject, reflectors. So if your question is not being answered right now, if you have one later on, no worries. In something like half an hour to the end of the presentation, I will again interrupt the PowerPoint presentation and answer your additional questions. But let's talk about exactly the next part. So we talked about the power that's coming out of the diffusing attachment and the color and what happens later, because that's not it. So what happens next is we have to shape the light. Okay, so I'm sharing this again with you. Let me check. Yes, there it is. Okay, so the LED F160, it's an effective shapeable light because it's a point light source. I come back to this later on. It's focusable. Let me just show this very quickly again, otherwise I forget it later on. So with this knob here, I can change not the lamp head's position, but the light source's position within the reflector. Okay, that's very nice for fine-tuning the light distribution of a reflector, if it's center weighted or super even, whatever. So like the Pulsar G heads, I can make the fine-tuning here. Right? Okay, and so going back to the presentation. So it's a focusable lamp head. It has a broncolor bayonet. Sounds logical, but it's a very important point. I grew up with flashlight. My entire career, I've been using a flashlight all the time. I know exactly what the P70 is doing. I know exactly what the Beauty Dish is doing. But when I had to shoot videos, I always had to translate. Okay, now it's a Beauty Dish, but what do I have to do with continuous light? Do I take an open phase or do I take a power reflector? If a power reflector, what kind of diffusion lens? Or should I build a screen and work indirectly? Whatever. So it was always quite tricky for me. If I have a lighting mood in my head with flash, it was easy. And with continuous light, it was always, woo, how do I do it? Now it's easy as well. Because I know my babies. I know my softboxes, my balloons, my paras, my open reflects, my grids. And it's the same, right? It's the same reflector. It's the same light geometry. So this is quite size-wise. The light source, this diffusing attachment is pretty much, is very comparable to a flash tube. So it has the same light geometry and therefore the same light moods, light characteristic. And this means I can shoot a still of a product or a portrait, and with exactly the same light mood, I can as well shoot moved pictures or videos. Okay, more about the point light source. These are two pictures of the LED chip. It's, let me check, it's about maybe 3 by 4 centimeters in nature. So that's with a macro lens. And on the left we have, I chose tungsten light balance, on the right daylight balance. So we see we use more of the cold white LEDs on the right, and the green and the red ones are more for the fine adjustment of the hue. Now, when you look at the LED like this, it's not a point light source. It's like, I don't want to count now, it's like 60 or 80 point light sources, and that's bad news. I want to work with one light, okay? Because if I have like 80 point light sources, I get, of course, 80 shadows. Another reason why we are using this tool at the very right side, which is the diffusion attachment, the different LEDs, they have different light angles. So let's say that the cold ones have a more narrow light angle, and the warm ones, the yellowish ones, they have a wider light angle. If you don't mix these lights properly with a diffusion attachment, you will have a colder light in the center and then a warmer circle around the light. And of course, that's absolutely a no-go. So this simple looking tool, this diffusing attachment, what you see on the right side, just looks like something very simple, but it's actually a lot of research and a lot of testing going into this tool, because it's very essential. It's the light source, right? It's not the LEDs. The LEDs are backlighting this diffusion attachment, and in the end, this is the light source, and you should really take care very, very well on your light source. So it has two jobs. Number one, it has to mix the lights, or the LEDs, it has to mix the different colors, and it has to unite them into one single light source in the reflector. If you choose a material that's optical too dense, the opacity is too high, you lose power. Okay, of course, it still mixes the light properly, but you lose a lot of power. So this goes back to the question just before. Is it enough to compare watts and watts? No, it depends a lot on this little diffuser here. So this has to be just opaque enough that it mixes the light, but translucent enough that it lets most of the light pass through. Okay. All right, so we have a point light source. Now, unfortunately, we have to do a little bit of math. So this is a parabola. And what you see in this parabola is we have this focus point F. And this focus point F is inside the curve. It's not, I don't know, outside or behind it, it's inside. Okay, so if we want, like in this drawing, the light beams that are actually leaving the reflector, or that they are parallel, we have to put the point light source into the focus point. Otherwise, the light is out of control, does what it wants, and we do not want to do the light what it wants. I want to control it. Okay, so the point light source has to be on the focus point inside the curve. Parabola, that's the shape that's most of the time used in reflectors, because most of the reflectors can be focused, for example, then the light leaves the reflector more or less parallel. It's more like a spot characteristic. Our paras, for example, they are not called paras because of the French word parapluie or paraguas in Spanish, which is umbrella, but because the shape, the mathematical shape is a parabola, right? Okay, so the important thing to remember here, focus point inside the shape. Ellipsis, maybe we want to have a reflector that focuses the light. Not, let's say parallel light is not enough, we want to refocus the light. These kind of reflectors are sometimes used in macro photography because they're actually focusing the light, all the light to a very narrow spot. I don't want to talk too much about the elliptical reflectors here, but check out, where are F1, F2? Inside the reflector. Again, if it should be effective, we have to have a point light source on the focus point position, and that's inside the reflector, exactly the same here. Again, we only have to check out the position of the focus points F1 and F2 of this hyperbola. So the focus points, again, are inside the reflector and not outside. So if we have the lamphead outside the reflector, or, for example, if we just have a lamphead that has a flat front, even if we push this into the reflector to the focus point, it does not have a light angle of 360 degrees, so it would not light the back of the reflector. So it's important that we have a point light source that has a light angle of more or less, or as close as possible to 360 degrees. And the important movement is this one. Okay, we have to push the light source, which is not the lamp head. The light source in this situation is the matte protecting glass, the diffusion attachment. This has to be on the focus point. And then from there, we can make the fine adjustment with the focusing tool. We can really go to exactly to the focus point, and then the light leaves the reflector as parallel as possible. Spot effect, or if we defocus it a little bit, we take on purpose, we take the focus point a little bit more into the reflector, so the light leaves the reflector a little bit more uncontrolled. So this is for a more even, more kind of diffused illumination. But again, if we want to control the light properly, we need a point light source, and we need it inside the reflector. And this is a point light source. The best would be if it's really like a flying point, but it's not a flat lamp head would not be beneficial because there's no light going behind to illuminate the reflector properly. Okay, so this is about open reflectors, and that's how our broncolor solution looks like. Here we cut a P70 standard reflector, and you see that the light source, which is the diffusion attachment, is at the right position inside the reflector. And in this situation, and only in this situation, you have a controllable, focusable light. And going back to the question I had before, like this, you make sure that all the light leaving the diffusion attachment is reflected and redirected to the object. So it's the unity, it's of course the watts that go into the lamp head, but then as well, how do we convert the watts into light? How do we mix the light? How do we diffuse the light? And how do we shape the light? All these parameters are essential for the light quality, for the control of the light. And so that's why only comparing watts and watts is just a small part of the truth. So that's why we recommend have a look at the light that's hitting your object, use a light meter, use a color meter, and then compare lights and lights hitting the object, and not just any fancy numbers in data sheets. Okay, and I mentioned the focusing option. So if you want to have the most light hitting the object, of course you focus it, but if you would like to have a wider and more even spread of the light, you defocus it a little bit. It's exactly the same what you're used to from pulsar G-head in open reflectors. Okay, so far about open reflector. What happens if we close our reflectors? Let's say we use softboxes. In this situation, you could say, puff, okay, it's diffused anyway. Who cares what I put in the back of my softboxes? I care, or we care here. So why? By coincidence, I have a softbox here. So let's say we have one of these pre-shaped LEDs, or these flat lamp heads that don't have a point light source that spreads the light in all directions. This means that the light is kind of pre-shaped and goes like this and like that maybe. Okay, but it's clear that it's heavily center weighted. Okay, to have the softbox evenly lit, we need as well reflections from the outer walls. These are coated in silver, and of course they reflect the light. They have a reasonable shape. They are not a perfect parabolic, of course, because it's only it has only 4 sides. But we have to illuminate these peripheries as well in order to have a perfectly evenly lit front diffuser, and that's what I care about with softboxes. So even inside the softbox, it does make a lot of sense that we have a point light source in here with a light angle as wide as possible, that the entire softbox is filled with light, and then the construction of our softbox is effective, and we get a even lit front diffuser and therefore a soft light. Okay, so don't underestimate this importance as well in softboxes. And why? Because we have taken care of this, if we look at the photographs, or if we look at 2 photographs taken with softboxes, we get exactly what we expect. And that's again from the same comparison like before. On the left, we have the LED F160 in combination with an octabox, with a small octabox with a diameter of 75 centimeters on the right side. We have the octabox 150. So how would it look if we would not illuminate the softbox properly? For example, the octabox 150 is a very narrow, it's not a very deep softbox. So if we are not taking care of the illumination of the softbox, it would be heavily center weighted. So the reflections, what you see on the leaning of the chair would be as aggressive as with the small one, and the shadows as well would be much harder because we only illuminate a small part of our front diffuser. However, with our lighting system, you get exactly what you expect from these lights. On the left, you get the more aggressive reflections and a sharper shadow because it's a smaller light. Then we increase the size of the surface by a factor of 4. And then on the right side, we have much softer shadows, and the light distribution is the light is distributed on a bigger area, and this means that the highlights on the shiny part of the chair are limited as well. So exactly what I'm used to from my flash photography, I get exactly the same with continuous light. So our LEDs are not pre-shaped, or our LED is not pre-shaped. This is a pre-shaped LED, or these are pre-shaped LEDs. Okay, as well, all the small components of our chip as well. They all have a little lens on top that actually accumulates the light, that it goes in the right direction. But then we diffuse it again with the diffusing attachment. So our light is not pre-shaped like these, and it does not produce any disturbing shadows. For example, I hope you can see it on the projection. Here we can clearly see on the surface, that's just a background wall in my studio, and that the illumination is far away from being even. So every little LED makes its own point. If you put something there, you will immediately get multiple shadows. You will get, 50, 100 shadows, very unpleasant. Okay, so again, because of the light construction, our reflectors are effective and the light is variable, like what you know from flash. Softboxes are evenly lit, otherwise they are not soft anymore. Softboxes turn into hard boxes if they are heavily center weighted, and light shaping can be advanced and complex. So it's not just a panel of LEDs that brightens up a scene. No, we can really very precisely shape the light, create different moods, and for this it's important that we have this kind of shapeability, point light source at the right spot inside a reflector. Good. So this was most of the tech talk. Now I would like to share and talk about a couple of photographs with you. For example, here. So this now, we talked about the lumens before. What we have here now on the left side, this tells me something as a photographer. Okay, I'm shooting with a shutter speed of 1/400th of a second. F is at 4, and the sensitivity is up at 400 ISO. I went a little higher with the ISO because I wanted to have a short exposure time or a short shutter speed. Because of course it's a model, maybe I'm not having the camera on a stand, and just to avoid any motion blur, I wanted to shoot with nothing longer than a 400th of a second. Talking about the color, the main light here is a fluter. So this is a special lamp in the end. It's a Fresnel spot with a diameter of about 40 centimeters, very beautiful, strong light. Very beneficial because it's really a lot of light is going there. So it's a spotlight that actually redirects the light. It's not like a honeycomb grid that just burns the light that tries to go left and right. So with a honeycomb grid, you are center weighting the light because you burn the light that tries to go left or right. With the fluter, it's a different story. You are redirecting the light that tries to go to the sides, and that's why you win a lot of light power. So that's why the fluter is the main light here. And then the shadow on the model's body is achieved with just a white cardboard that I put in between the fluter and her. And then I fill in indirectly with a second LED via this white wall. And there I put the color temperature to 6,500 Kelvin. Okay, the camera is the same white balance setting like the main light. So the fluter is on 3000, the camera is on 3000. That's why the skin tone is normal. But then the fill-in light and let's say that the dark parts of the background, then these are of course much colder. So this is just shot with 2 LEDs, no color filter needed. Just nice color shift in the shadows. Of course, if I shoot still life, I do not care about shutter speed at all, because if I put the camera on the stand, these deo sprays don't really move too fast in my set. So I don't have to cheat at all here with the camera settings. I can shoot it at f16. Which means enough depth of field, ISO 100, which gives the best result. And then exposure time, shutter speed is 1 second because everything is standing still. Beside this, the trick is the same like the portrait I've shown before. The main light is a large softbox coming here from the right top. I set there the color temperature of the LED to 3200 Kelvin and the same setting on the camera. So the camera most of the time goes together with the main light, and then with the rest you play creatively. So here it's the underlight, kind of fill-in light as well, and the underlight under this acrylic plate where the sprays are lying on, I set this there to 6400 Kelvin. So that's why I get this cold, fresh light coming through. You see it as well a little bit on the contours of the object. Again, with no filters needed for this, just fine-tuning the color on the back of the LED. If you would like to know more about this, there is a how-to where Carl Taylor and myself are using 3 LEDs to make a white-on-white e-commerce shot of 2 shower soaps. You find them on our website, broncolor.swiss. You go to the Learn section, and there are a total of 31 how-to videos like this one. And so this one is 11 minutes, so they are between 6 and 11, 12 minutes. So if you have the time, if you would like to get inspired by these 2 clowns here, just go to our website and have a look at a couple of how-to videos like this one that we realized with the LEDs. Good. Then let's talk about location. So beautiful sunlight still in the background, but I was too late. Okay, I didn't work fast enough, so the sun is already behind the horizon for the model. So we have a beautiful background, you have a beautiful model in the water, but you're too late. What do? You take an assistant that's cool enough to go into the cold water with you and holding the battery-operated LED in this situation. I will show, I can do it right now, otherwise I forget it. Let me show quickly how this works. So this is the size of the battery for the LED. So it's a little bigger than a Xerox battery, not a lot, just maybe more rectangular, pretty much the same size. And we don't need the ballast unit anymore, so the lamp head, the light goes directly into the battery and is ready to go. Right, okay. On full power, like it's now, you have half an hour on full power light. That's quite a lot for this small battery, and then it's more or less linear. So if you go down to 9, okay, we consume half the power, so that's why I get almost 1 hour of light from one single battery. So that's very, very convenient on location. And yep, I switch it off again, otherwise I'm turning too dark here. Okay, so go back to my location with the artificial sun. Yep, okay, there we go. I hope you see it. Let me check. Yes, there it is again. Okay. So it's just a normal reflector. I used here the L40 reflector, which is just a little bit smaller than the P70 standard reflector. You see that the cable of the lamp head is actually in the water. I would personally not recommend this, but of course, if it's only the cable, it's absolutely okay because the cable is isolated. Nevertheless, before you pack it, make sure that you dry the cable properly. And the result then is this one. Okay, so again, the beautiful sun in the background, and now my artificial sun from the front. If you look at the blouse she's wearing, it's not a perfect white, right? It's a little warm tone white. So again, I was not working on the standard setting, which is maybe daylight, because it would look daylight in this setup would look very synthetic, would look unnatural, much too cold, not pleasant. So here I asked the assistant just to go down maybe to 4,000 Kelvin, maybe 3,800 Kelvin, something like this. Not really all the way to tungsten. This would be too yellow, but just to give a tiny warm touch to the setup. So this is really an extremely convenient feature of this light. This was actually the first shot of the day, this portrait where the model is lying on the stones. It was a bright afternoon. Well, you see the sky was clouded a little bit. So if you work on the full daylight, there you reach the limits of the LED F160, especially when you work with a double diffused light in a softbox. So that's why we have been hiding a little bit in half shadow under a bridge. And then the main light is the softbox that my assistant holds here from the right side, just to support the direction of the light. Otherwise, I have only this diffused, boring, cloud-covered sky. And then as a fill-in light, I have just an umbrella reflector very, very close to the camera as a fill-in light for the other side, because otherwise it would be completely dark there. You see the fill-in light when you look at the final shot on the right. You see that the shadows of these stones, of these rocks, are very sharp, and that's the fill-in light. I like these kind of hard fill-in lights as long as they are close to the camera, because they don't create any secondary shadow in this situation. And like when you look at her sweater, even in the shadows, the sweater just has a beautiful, the wool is almost like glowing, so a lot of texture, and that's the benefit of a hard fill-in light. But it has to be close to the camera. Let's have a close look at it. On the eyes, you see several things. What looks like wrinkled softboxes, the large grayish areas, this is the sky. This light, of course, looks very cold, or it would look very cold if I did not have there my octabox, the octabox 75. And again, I dialed it to be a little bit more warmer than daylight. That's why I get this beautiful skin tone on the model. The fill-in light is just a white point here. That's not because it's daylight balance, because it's just so bright. I don't know if you joined my webinar about light and skin. So if we have a small light source, the highlight of small light sources are just burnt, and of course loses all the color. So that's why this point is white, but you see it, how beautiful the color of the model is as well in the shadow side. And the last thing about this, the detail really extremely zoomed in proves that with these LEDs, you can work with a shutter speed that's absolutely short enough. I'm not using a stand here. The model is alive, moves a little bit, but I can shoot absolutely sharp as well with a LED, even on location. It's a big subject. It's always this question, is it strong enough when I go outside? Yes, this proves it, that it is strong enough. Yeah, that's what I wanted to say with these details. Here, this is the last shot of this shooting. So the sun is already behind the horizon, so the entire scene is much darker. So that's why we came out or away from the bridge. We did not have to hide under the bridge, because it was already dark enough. And in such a situation, of course, you have by far plenty of light to dominate the rest of the environmental light. But if I'm here on this very open stage and it's a sunny day and the sun hits the scene, then I would still bring flash, to be honest. But as soon as you can control the light situation a little bit, if you can go just hiding under a bridge or any indoor situation, of course, would be absolutely sufficient to control the light. And it's all possible thanks to this setup. The stand, well, I just put the feet away, and then my assistant did hold the stand, and the battery is there already on the light, so you can go wherever you want, and it's very flexible, super fast to move around with this light. And that's the reflector you see here. That's this L40 reflector that I mentioned before. Super compact, nice sunlight imitation, as simple as it is, but a nice sunlight imitation. So very, very convenient set, what you see here. All right, then almost the last thing. If you want to control your light with DMX, we are prepared for this as well. We have a DMX box. I would like to show this to you as well quickly here. That's even smaller than the battery. Battery was before. DMX box is more or less half the size. So you can connect several LEDs and you can control them from your control panel. So it is ready for DMX control if needed. If you work like this, and this is the picture that should illustrate this properly. Exactly. And then a big subject for me, and this is the preview to next week, shaping the light with LED and combine it with flash. Okay. Let me show the detail of this shot here. So what you see in the hair of the model, obviously we have here some wind in the model's hair, and we have a nice motion blur on parts of the hair, but some other hair are completely sharp, absolutely frozen, as is the face or the eye of the model. So this is the typical result. If you combine continuous light on parts of the shot and some flashlight on other parts of the shot, it's the potential, the creative potential is immense if you start combining. So it's already a nice lamphead by itself, but combining it with flashlight like a compact, like a monolight Ceros, or as well Score with Pulsar Gs and the Unilights, it's amazing what kind of mixed light situations you can create. So to summarize, before I go back to the questions, so make sure you type in your questions right now. So to be in full control of your continuous lighting regarding light shaping, the color and the power, the LED F160 is first choice. Now, the presentation was a little differently. Now I prioritized light shaping, which is for me really the most important one, color and power. So for me, from a creative point of view, that I can shape the light of this LED properly, this is really the key point for me. You can do this in the studio and on location. If you go on location, very convenient. The battery, compact battery with half an hour of full power light in it. Of course, you can use it for still photography and people photography, and you can combine it with flash, as we will see in 1 week from now here during the live shooting webinar from the studio. Right, this was it from the PowerPoint side, which means I'm going to finish the presentation and we'll have a look at the questions. Okay, so the first question is a great but question. Let me know what is the but. I need to know if I can compare my actual flashes using the... Okay, I need to know if I can compare my actual flashes with this F160 in terms of F number, using a standard reflector, measuring with a photometer, ISO 100, 120 fifth of a second, 1 meter. What F number would I reach? I don't have a light meter right here with me. Let me give you a guess. I would say 1 meter, that's really close. I would estimate at ISO 100, 125th of a second, somewhere between 5.6 or 8. That's a guess. You have seen the portrait before over several meters with a fluter. This was 400 f4 and a 400 of a second. Okay, so 400 of a second to a 125th. We already win 2 f-stops, but we lose them again on the ISO. So I would say that it's absolute, especially over 1 meter, that's extremely close. I would really say that you on a 125th of a second, you would easily get a 5.6 to 8. And I mean, I really don't know what kind of light you're using, but most of the advanced light as well, like the small lights, of course, you can dial them down. If it's really not enough, if you need less flashlight, there are still gray filters around. But as I said, in the studio, I have never any issues combining it with flashlight, still working on normal apertures. Yes, the Bron website states that the glass diffuser and new firmware increases the output by 15%. Does this, what does this increased output mean in terms of f-stop? Some math again, sorry. If it would increase the output by 100%, we would have 1 full f-stop more. So it's about 15% more. So I would say it's about max 1/3. It's maybe 2/10, 1/3 of an f-stop more. So it's not a new category, but it's more light. Okay, but it's not double the power. I have a question about using color checker for continuous light, because according to your talk, we have various temperature lights. Which temperature of light is correct? The one that looks the best, I would say. I mean, there is a correct. If I shoot this kind of objects, black objects, let's say, if I want this object to look 3-dimensional, I have 3 different gray values. Okay, gray values means that the tiniest color temperature shift is immediately jumping to my eye, and if it's not neutral, it's disturbing if one side is green and the other one is too warm. So in this situation, there is a correct. The correct is black, looks like black. Neutral, there is no color temperature shift. RGB, the 3 channels have the same value. Okay, let's say on the black they are like 30, 30, 30. On the bright gray they are like 50, 50, 50. On the bright front they are maybe 80, 80, 80. So it still looks black but neutral. So there's a correct. In this situation, the correct is the light has the same color temperature like the camera, or very simple gray balance on the object. But all the other portraits I showed to you, let's say the shot where the model had a blue light here, or where I imitate the sunset, what is correct? I think what looks natural in the shot, that brings a nice skin tone, that imitates the sunlight, the sunset a little bit, that's correct. But if I would set up a correct daylight in this situation, it would be in a way correct, but it would look very bad, very cold, very synthetic on the photograph. So in the end, it's much easier. Don't believe, or don't choose any value that you think from your brain tells you that this is the value you have to choose. Just look at the photographs. I mean, as photographers, we are working with our eyes. Whatever looks good, it's exactly correct. Okay, the same is with light shaping. I get so many times I'm asked, what is this light shaper for? What is this light shaper for? It's for photography, and when you create a picture with it that looks good, it's exactly the best use. And here it's the same. Of course, if you, let's say you shoot fashion and you have to rely that the color of the textile is shown the correct way in a photograph, the thumb rule, of course, is the color temperature on the light is the same color temperature than you use on the camera. However, I repeat myself, I rather do this with a gray balance, because if you put this one on 5000 and your camera on 5000, that's not yet a guarantee that this 5000 is the same 5000 like Sony, like Nikon, like Canon, like Hasselblad, like, I don't know, Fuji, whoever is around on the market. So just gray balance and then you're fine, or trust your eyes. Good. Okay, so there are no more questions coming in. The presentation is done. I explained everything I want. So just let me remind you once more to next week, same time, same studio. I will have a dancer here from Germany, and she will do some amazing movements, and I will try to capture this movement and show the movement with continuous light. And at the same time, I will try to get absolutely sharp photographs. So that's why I'm going to combine this continuous light shooting LED with flashlight. Okay. If you remember a question that you forgot to ask today, remember 2 days from now, Friday afternoon, 2 p.m. Swiss time, I will be here in the studio again on the broncolor Instagram channel, answering your questions during a live chat. Okay, this was it for today. Thank you very much for your time. All the best.